Hello, grade 9 students. Let's continue our lesson on the properties of quadratic functions. And this is now part 3 of our lesson on properties of quadratic functions, particularly the characteristics of quadratic functions. Let us first have a warm up before we proceed to the lesson proper. Find the x-intercept of each linear function. Okay, how do we solve this? To solve for the x-intercept, the y-intercept. So for the y-intercept, that's easy, right? Negative 3, 6, 7/3. But how do we solve for y-intercept? I mean the x-intercept. You just let y equal 0. Okay? Solve for the x-intercept. So for number 1, what is y? 3 halves. Yes. So pag 0 yan, 2x equals 3. So divide both sides by 2. So 3 halves. Next, how about here? Number 2. If y is 0, what is the x-intercept? 7 halves. And for number 3, if y is 0, negative 2 is the x-intercept. Next, evaluate each quadratic function for the given input values. y equals negative 3x squared plus x minus 2 equals, when x equals 2, what is y? Okay, what's your answer? Substitute x equals 2 here in the equation. Your answer is negative 12. Okay, did you get the same answer? How about number 5? Y equals x squared plus 2x plus 3 when x equals negative 1. I think you can do it already. 1 minus 2 plus 3. The answer is 2. Positive 2. Okay. Objectives for this PowerPoint presentation. Find the zeros of quadratic functions. Function from its graph. Find the axis of symmetry and the vertex of a parabola. There are two vocabulary for this topic: zero of a function and axis of symmetry. Recall that an x-intercept of a function is a value of x when y equals 0. A zero of a function is an x value that makes the function equal to 0. So a zero of a function is the same as an x-intercept of a function. Since the graph intersects the x-axis at a point or points containing an x-intercept, these intersections are also the zeros of the function. A quadratic function may have 1, 2, or no zeros. So it says here, the zero of the function is just the same as the x-intercept function. It is where the point of intersection between the parabola and the x-axis. So, kung saan man nag-touch yung parabola and the x-axis, those are the zeros of the quadratic function. It may have 1, 2, or no zeros. When say 1, it will only touch the x-axis at one point, which is the vertex. When 2, it will touch the x values, means the x-axis twice, or no zeros. So when say no zeros, the parabola does not touch the x-axis at all. Sample 1a, finding the zeros of quadratic functions from graphs. Find the zeros of the quadratic functions from its graph. Check your answer. Y equals x squared minus 2x minus 3 here. That's very easy. You can easily determine the zeros of this function. Based from the graph, the zeros appear to be negative 1 and 3. There. Points of intersection between the x-axis and the parabola. Negative 1 and positive 3. Let's check. Substitute the values of negative 1 and 3 to the equation y equals x squared minus 2x. So if x negative 1, we have 1 plus 2 minus 3. 3 minus 3 equals 0, correct. If 3 is 9, if x 3, we have 3 squared, 9 minus 6 minus 3 equals 0. 0 equals 0. So correct. These are the zeros of the quadratic function. Y equals x squared minus 2x minus 3. About here, find the zeros of the quadratic function from its graph. Check your answer. Y equals x squared plus 8x plus 16. The zero appears to be negative 4. So there is only one 0 for the quadratic function because it touches the x-axis only once, which is at negative 4, and that is what we call That is actually the vertex of the parabola. So if you check, substitute the value of x, negative 4, to y equals x squared plus 8x plus 16. Check ba? 16 minus 32 plus 16 is 0. 0 minus, yes. Yes, 32 minus 32 is 0. 0 equals 0. Check. Helpful hint, notice that if a parabola has only one 0, the 0 is the x-coordinate of the vertex. That's right. Example 1c, finding the zeros of a quadratic functions from graphs. Find the zeros of the quadratic function from its graph. Check your answer. Y equals negative 2x squared minus 2. The graph opens downward because a is negative. A is less than 0. So what are the zeros? Okay, the graph does not cross the x-axis, so there are no zeros of this function. Only y-intercept, which is negative 2. But this time there are no zeros because it does not touch the x-axis. Next, find the zeros of the quadratic function from its graph. Check your answer. Y equals negative 4x squared minus 2. Again, it opens downward. Here, it opens downward. Okay, find the zeros. The answer is the graph does not cross the x-axis, so there are no zeros of this function. There are no zeros because it does not touch the x-axis. Next, find the zeros of the quadratic function from its graph. Check your answer. Y is equal to x squared minus 6x plus 9. 0 appears to be 3. Yes, the point of intersection between the parabola and the x-axis is 3. So that is the 0 of the quadratic function. And if you're going to check it, we have 3 squared minus 6 times 3 plus 9. 9 minus 18 plus 9 is 0 equals 0. A vertical line that divides a parabola into two symmetrical hubs is the axis of symmetry. The axis of symmetry always passes through the vertex of the parabola. You can use the zeros to find the axis of symmetry. When there is one 0, use the x-coordinate of the vertex to find the axis of symmetry. For example, if the vertex is at 3, 0, therefore the axis of symmetry is x equals 3. Or that means x is equal to h. Because the vertex is hk. So h is 3, k is 0. So x equals h. So whatever the value, x-coordinate of the vertex, or whatever the value of h is, that will be the axis of symmetry equated to x. X equals 3. Now, if it has two zeros, use the average of the two zeros to find the axis of symmetry. For example, the zeros are negative 4 and 0. Then, get the average of negative 4 and 0, that's negative 2. Therefore, the axis of symmetry is x equals negative 2. Yun, gano'n naman pag two zeros. Or just determine the vertex, which is at negative 2, negative 4. What is h in the vertex? Negative 2. So x equals negative 2. So pwede rin yan average of the two zeros. Next, finding the axis of symmetry by using zeros. Find the axis of symmetry of each parabola. Letter A. First, identify the x-coordinate of the vertex, or identify h of the vertex. Negative 1, 0. So therefore, axis of symmetry is x equals negative 1. How about B? Find the average of the zeros. There are two zeros here. So we have 1 and 4. 1 plus 4. 5 divided by 2. 2.5. Therefore, the axis of symmetry is x equals 2.5. Here. That is the axis of symmetry, the line that divides the parabola into two hubs. Next, find the axis of symmetry of each parabola, letter A. Then identify the x-coordinate of the vertex, negative 3, 0. Therefore, the axis of symmetry is x equals negative 3. X equals h. How about B? Find the average of the two zeros. Negative 2 plus 4 divided by 2 is 1. 2 divided by 2 is 1. So therefore, the axis of symmetry is x equals 1. Right? If a function has no zeros or they are difficult to identify from graph, you can use a formula to find the axis of symmetry. The formula works for all quadratic functions. So the formula is x equals negative b over 2a. And that is actually the formula for h in the vertex. For a quadratic function, y equals ax squared plus bx plus c, the axis of symmetry is the vertical line. X equals negative b over 2a. So for example, we have here quadratic function y equals 2x squared plus 4x plus 5. What is the axis of symmetry? The formula is x equals h, or x equals negative b over 2a. b is 4, a is 2. So substitute negative 4 times over 2 times 2. It's 4 divided by 4, negative 1. X equals negative 1 is the axis of symmetry of this quadratic function y equals 2x squared plus 4x plus 5. Find the axis of symmetry of the graph y equals negative 3x squared plus 10x plus 9. Step 1, find the values of a and b. A is negative 3, b is 10. Step 2, use the formula x equals negative b over 2a to find the axis of symmetry. The answer is 5/3, 10 over negative 6. Negative 10 over negative 6, 5/3, positive. The axis of symmetry is x equals 5/3. How about this? Find the axis of symmetry of the graph of y equals 2x squared plus x plus 3. Step 1, find the values of a and b. A is 2, b is 1. Step 2, use the formula x equals negative b over 2a. Substitute. Negative 1 over 2 times 2 is negative 1/4. Therefore, the axis of symmetry is x equals negative 1/4. Diba? Very easy lang. So once you have found the axis of symmetry, you can use it to identify the vertex. Finding the vertex of the parabola. To find the x-coordinate of the vertex, find the axis of symmetry by using the zeros or the formula. To find the corresponding y-coordinate, substitute the x-coordinate of the vertex into the function and write the vertex as an ordered pair. Example, find the vertex of the quadratic function y equals 0.25x squared plus 2x plus 3. First, to solve for the x-coordinate of the vertex, we have negative b over 2a. But wait, the zeros are negative 6 and 2, negative 2. Get the average, which is negative 4. Negative 8 divided by 2 is negative 4. So the axis of symmetry is x equals negative 4. Step 2, find the corresponding y coordinate. Use the function rule. So from after solving for values of x, the value of x, substitute the value of x by negative 4. Yun. The answer is negative 1. Therefore, the vertex is negative 4, negative 1. Okay. Find the vertex, for example, 4b. Y equals negative 3x squared plus 6x minus 7. Step 1, find the x-coordinate of the vertex. Identify A and B. Negative 3 for A, B 6. Solve for the x-coordinate of the vertex by using the formula x equals negative b over 2a, which is the same as the formula for the axis of symmetry. The answer is 1. Negative 6 over 2 times negative 3. Negative 6 divided by negative 6, 1. Positive 1. So the x-coordinate of the vertex is 1. How about the y-coordinate? Substitute 1. Use the function rule. Substitute the value of x, which is 1, to the original equation. Yun. Negative 3 times 1 squared plus 6 times 1 minus 7. We have negative 3 plus 6 minus 7 is negative 4. So therefore, the vertex is 1, negative 4. Can you follow, class? I hope so. How about this? Find the vertex. First step, we need to solve for h, or the value, the x-coordinate of the vertex, which is equal to negative b over 2a. So first, identify and b. A is 1, b is negative 4. So to solve for the x-coordinate of the vertex, we have negative b over 2a. Substitute 1 for a and negative 4 for b. So we have here negative 4 over 2 times 1 is positive 2. So the x-coordinate of the vertex is 2. Now let us solve for y. Substitute 2 in the original equation. Substitute x by 2, I should say, so that you can solve for y. Use the function rule. So 2 squared minus 4 times 2 minus 10 is 4 minus 8 minus 10. The answer is negative 14. 4 minus 8 is negative 4 minus 10, negative 14. So the vertex is 2, negative 14. Application. The graph of f of x equals negative 0.6 x squared plus 0.6 x plus 10.26 can be used to model the height in meters of an arch support for a bridge, where the x-axis represents the water level and x represents the horizontal distance in meters from where the arch support enters the water. Can a sailboat that is 14 meters tall pass under the bridge? Explain. So the vertex represents the highest point of the arch support. The arch is in the form of a parabola. First, we find the x-coordinate. Identify a and b in the given equation, that is a negative 0.6, b 0.6. Let us now solve for the x-coordinate of the vertex, which has the formula negative b over 2a. Negative 0.6 all over 2 times negative 0.06. The answer is 5. Now to solve for the y-coordinate, use the function rule, substitute x by 5. 11.76 is the answer for y. Since the height of each support is 11.76 meters, the sailboat cannot pass under the bridge. Yes. Why? Because sailboat is 14 meters tall. So what we have solved here is 11.76 only. So the sailboat cannot pass under the bridge. It has to be taller. Next, the height of a small rise in a roller coaster track is modeled by f of x equals negative 0.07 x squared plus 0.42 x plus 6.37, where x is the distance in feet from a supported pole at the ground level. Find the greatest height of the rise. So this is a parabola that opens downward because a is negative. First, step 1, find the x-coordinate. Identify a and b. A is negative 0.07, b is 0.42. Let us now solve for the x-coordinate of the vertex. Formula negative b over 2a. The answer is 3. So negative 0.42 divided by 2 times negative 0.07 is 3. Now find the corresponding y-coordinate. Use the function rule. Substitute the value of x, which is 3, to the given quadratic function, equation of the quadratic function. So the answer is 7 feet. So the height of the rise is 7 feet. So let us now have here our lesson quiz part 1. Find the zeros and the axis of symmetry of the parabola. You can see it in the graph. Number 1. The answer, zeros, negative 6 and 2. Kasi sa graph niya, 2, 4, 6, 2, 4, 6, 8, 10. So negative 6, 2 are the zeros of the quadratic function. How about the axis of symmetry? Axis of symmetry is yun. Get the average of negative 6 and 2, negative 4 divided by 2, so x equals negative 2. Next, find the axis of symmetry in the vertex of the graph of y equals 3x squared plus 12x plus 8. So, axis of symmetry, and the x-coordinate of the vertex has the same formula, which is negative b over 2a. So, for the axis of symmetry, x equals negative 2. Negative 12 over 6. So negative 2. X equals negative 2 is the axis of symmetry. So same is true with the x-coordinate of the vertex, negative 2 rin. Then substitute negative 2 in the equation to solve for y, which is negative 4. 3 times 4, 12. 12 minus 24, negative 12 plus 8, so negative 4. Tama. And lesson quiz part 2. The graph of f of x equals negative 0.01 x squared plus x can be used to model the height in feet of a curved arch support for a bridge, where the x-axis represents the water level and x represents the distance in feet from where the arch support enters the water. Find the height of the highest point of the bridge. The answer is 25 feet. So I want you to show me the solution and send it to my messenger. Private message in the messenger. Okay, 25 is the answer. So that ends our lesson on the properties of quadratic function. This is part 3. Meron pang part 4. I'll see you next time. Goodbye.